Okay, we finish up this topic first, then we enter the revision. Sorry, the exercise. Okay, we discuss. Your midterm until chapter 2, is it?
3.1.
3.1.
Ha.
Chapter 3 memang tak sempat lah. Just one subtopic, right? You can do by own, right?
I can, sir.
Okay. So the important one is the essay that related in chapter 2 lah. That is most important one. Okay, come. Let's enter weight. Weight paling ringkas dia punya subtopic. Dia 2 page saja. Okay. Baik, kita tengok. Because only one learning outcome, you must know that W equal to mg. Okay. This W equal to mg we will use in various topics. So you must understand this formula very well. Okay. Weight and gravitational acceleration. What is with them? What is the relationship? Let us see here. The weight, as we all know, weight is a type of force that act accordance to the gravity. Okay, the weight of an object is defined as the force of gravitational. It's actually the gravity force lah. Okay, force of gravitational which is exerted on it by Earth. Okay, for example, kita ada satu objek di atas bumi. Bumi means in the earth, not necessarily on the land lah. Anywhere, we found a gravity force on the object, then we call it weight. Okay, so first let us look at the basic formula for the force. Force equal to ma. Since weight is the force of gravity acting on an object of mass m, okay, weight ni sejenis force that bertindak pada satu objek that has the mass m, then it make fall with an acceleration g, okay, because everything in the earth will fall under the value of g, right, 9.81. So we rearrange the equation, okay. So the force kita tukar nama dia kepada weight because weight is a type of force. Mass kekal, acceleration untuk weight dia adalah acceleration ke pusat bumi, towards the center of the earth. So jadi kita ambil gravitational acceleration. Gravitational acceleration. Maka terbitlah dia punya formula W equal to mg. Baik. Jadi saya tak buat apa-apa perubahan. Saya hanya bagi tahu nama lain untuk force, nama lain untuk acceleration. Okay. W equal to mg. This g is acceleration due to gravity atau kadang-kadang kita panggil gravitational acceleration sajalah. Gravitational acceleration. Dia sama je. Okay. Right. So, apa unit bagi weight? Mestilah Newton because weight is a type of force. Must remember that. Okay. Right. Now, gravitational acceleration and gravitational field strength. Apa benda dua benda ni? Dua-dua sama. Okay. Kalau nak cerita pendek, dua-dua pun sama. Okay. Gravitational acceleration is the object when fall down, it will experience an acceleration which is due to gravity, which having 9.81 ms negative 2. Dan kita punya medan kekuatan graviti, gravitational field strength, also 9.81 Newton per kg. Okay, baik, kita akan tengok benda ni dengan lebih mendalam. Okay, a gravitational field, okay, is the gravitational field ni medan graviti lah, is the region which an object experiences a force due to gravitational attraction. Apa benda ni? Okay, kita tengok. This is our Earth. Our Earth, everywhere, wherever, when we all know that everywhere in the Earth is surrounded by, is experiencing the gravitational force, right? So everywhere in the Earth is a gravity field. Okay, something like this. Okay, gravity field. So gravity field strength ni, dia lebih kurang the force that you experiences in accordance with the gravitational attraction. Daya yang kita experience disebabkan oleh tarikan graviti. Itu yang kita panggil gravitational field strength. Okay, gravitational field strength is defined as the What of the weight to the mass of the ratio? Ratio of the weight to the mass of the object or weight per unit mass. Apa benda ni? Okay, kita cuba susun kita punya equation. W equal to mg kan? Okay. This g got two definition. One is acceleration due to gravity dan satu lagi adalah gravitational field strength. Okay, if you make the g as a subject, your weight is over by your mass. You will get your g. Sebab tu kita panggil ratio, hasil bahagi. Ratio of the weight to the mass of the object, or you also can tell weight per unit mass. In short. So, apa unit bagi G ni pula? Okay, kamu tengok. Weight dia adalah Newton. Mass adalah kg. Kg kat bawah. Kita bawa ke atas, dia akan jadi kg negative 1. Okay, that's why I tell you just now, 9.81 Newton per kg. Okay. Jadi, kena ingat, G ni ada dua maksud. Satu boleh jadi 9.81 ms negative 2. That means acceleration due to gravity. Another meaning is 9.81 Newton kg negative 1. The meaning of this is gravitational field strength. In conclusion, dua-dua sama je. Nama lain, pet name. Okay, for now you can think like that. Of course, when you go to higher level, things will be different. Okay, for Earth, or these two value is the meaning the same. Okay, right. Yeah, they're explaining the same thing that I explained just now. Okay, weight over mass is equal to the gravitational field strength, and then you get the same formula. So in a nutshell, G equal to gravitational acceleration dan G juga equal to gravitational field strength. Dua-dua benda yang sama. Dua-dua pun dia punya unit pun lebih kurang sama je lah. Actually meter per second dia mesti sama juga dengan n kg negative 1. Okay, tak percaya, kita tengok. Kita cuba buktikan kenapa yang dua ni betul. Dia equal. Kamu tengok. Newton ni daya. Okay, is force. So macam mana kita dapat Newton? When you get mass times acceleration, right? Mass is kg. Acceleration is ms negative 2. Okay. So now, Newton kg negative 1. Apa maksud dia? Untuk Newton saja, value dia adalah kg ms negative 2. Okay, untuk kg negative 1. Kita tambah kg negative 1. Maksud, this kg and this kg will cancel each other. Jadi tinggal apa? ms negative 2. Sebiji dengan yang ni. Boleh faham? Or do I went so fast? Sorry, I couldn't hear you. Is it my mic? Can you speak louder?
Can understand, sir.
Can understand. Okay, alright. Wait, let me find my... Where's my headset? Okay, here. Give me a moment. Dalam... Okay. Dalam fizik kan, kalau dia punya unit sama, maksudnya dia punya physical quantity pun lebih kurang sama lah. Itu maksud sebalik dalam fizik. Okay. Dia ada banyak example I can show you like that. Okay. Right. This is one of the example. If you rearrange the Newton kg negative 1 into base units, you are getting the ms negative 2. Same like gravitational acceleration. That's why kita cakap dua-dua benda ni sama. Okay. Right. Changing in weight, fixed mass. Yes, that's true. People oftenly ask us, what is your weight? But that is not the right question. The right question supposed to be, what is your force? Okay, so what is your mass? Okay, kalau weight kita kena cakap dalam Newton apa? Kalau orang tanya weight berapa, kita cakap 60 kg. Kita jawab pun salah, dia tanya soalan pun salah. Maksudnya dia tak practice dia punya fizik. Okay, mass dia adalah 60 kg. Kalau weight apa dia? mg kan? This 60 you must times with 9.81. Kalau kita times dengan 9.81, 60 times 9.81 kan? Kita akan dapat 588.6. Nanti dia terkejut. Tapi cakap lah Newton baru dia faham. Okay? Jangan cakap kg. Okay? 588.6 Newton. Ini contoh calculation dia. Okay. So, our weight is depends, our mass won't change. But, our weight is influenced by the gravitational acceleration. Kalau ke bumi, tak apalah 9.81. So, when you go out of the bumi, like you go to space, tak ada gravity langsung. Zero lah. When you go to the moon, our moon is like divide 6 lah. Kita punya gravity divide 6 baru kita dapat moon punya gravity. Jadi kat sini kamu gemuk, pergi moon kamu dah slim dah. Macam tu lah lebih kurang dia. Okay, on the moon, our weight will be less than Earth because the moon gravitational field is smaller. That is 1/6 of gravity of the Earth. 1/6 gravity of the Earth. Okay, the value of the... Oh, dia dah bagi soal nombor 2. The value of the gravitational... Yeah.
106 ni tetap lah, takkan berubah.
Yeah, lebih kurang lah.
Okay.
The value of the gravitational acceleration on the moon is 1/6. The value of the G on the Earth. Alright. Even on Earth, our weight can vary slightly because I already told in previous lesson, our G value is not the same at everywhere in our Earth. Ada yang dia punya G tu dia berubah kan? 9.81 dekat North Pole or South Pole dia akan berubah sikit dia punya G value. Okay? But moving away from the Earth, our weight change. If we could go deep into space and be free of any gravitational pull, our weight will be 0. Because no G, no gravity means no weight. Because weight ni disebabkan oleh gravity. Kalau gravity tak ada, weight tu tak wujud. Okay? Whether on Earth or on the moon or on the deep in the space, our mass does not change. Our mass does not change. Okay, remember that. Okay? Right, our weight change according to the gravity, but our mass, regardless, everywhere, it will be stay the same. Right, for example, kamu tengok, kita ada di angkasa lepas, deep in space, 100 kg, right? But your weight is 0 Newton because due to what? G equal to 0 here. This one, 1/6 times 1000 Newton. Actually, not 1000. Because they're assuming the G equal to 10 here. That's why 1/6 times 1000 lah. Okay. At the Earth, actually, we try to make the correction here. Okay. Please correct this. This is not like that. The weight here should be, because last time in the syllabus, we used 1 kilogram is equal to 10 Newton. But not anymore because the G is 9.81. So 1/6 times 9.81. This is the 1/6 of the gravity bumi. Then you multiply your mass. Ini baru kita akan dapat tentang moon. Okay, berapa value dia?
Under 63.5.
Under 63.5 Newton. Yang ini dekat sini 100 times 9.81. So 981 Newton. Okay. Dekat bulan 163.5 Newton only. Nampak? Okay. Right. Let's go to the next part, calculation. Okay. A spacecraft from Earth to Mars, where the gravitational field per strength near the surface is 3.7 Newton per kg. Dia pergi Mars. The spacecraft is carrying a probe which has the mass 100 kg when measured on Earth. What is the mass? What is the probe's weight on the Earth? Dia tanya dekat bumi. Okay. At the bumi, okay, dia tanya weight kan. Weight equal to mg lah. So, the mass is 100 times the g is 9.81. So, 981 Newton. Okay, question B. What is the prop's mass? Mass dia tak perlu kamu bimbang. Dia semua tempat sama je. 100 kg.
Sir, why
Ya,
kena sama?
mass tu tak akan berubah.
Oh,
Dia tak
weight.
tanya weight. Dia tanya weight baru kita letak kosong.
Weight
Ah,
tu berubah lah.
weight tu akan berubah mengikut gravity.
Oh, sebab formula dia ada gravity tu.
Yes,
Oh,
yes.
okay, okay.
Mass dia tak akan berubah. Mass tu apa dia? Mass tu the amount of particle in a substance. Kita belajar dalam chemistry kan? Kita ada particles kan dalam setiap bahan tu. Satu mol bahan tu dia ada 6.02 times 10 to the power of 23. Avogadro constant. Which is equal to their respective molar mass. Itu baru satu mol punya mass. Dia ada banyak particle, dia banyaklah mass dia. Itulah mass dia. Mass tu apa? Dia punya particles punya weight lah, mass lah. Alright? Amount of matter in an object. Itu yang kita panggil macam tu. Definisi untuk mass adalah amount of matter in an object. Matter tu apa dia? Particles lah. Right? Okay. What is the prop mass on Mars? Untuk Mars, kita ambil Mars punya gravity lah. Okay. 100 you times with 3.7. So you get 370 Newton. Okay. And finally, what is the prop's weight on Mars? Oh, sorry. Dia tanya mass. Okay. Weight yang saya buat untuk soalan D. Okay, soalan C, mass. Mass dia kekal sama. Dia mass ke? Dia adakah space ke? Dia adakah earth ke? Mass dia tak akan berubah, sentiasa 100 kg.
Okay, done, sir.
Okay, done. Very good. Good thing. You do very fast. That's good. Okay, next. Example 2. An object of 8 kg weighs 120 Newton. Okay. What is the gravitational field strength of the planet? Dia tanya G itu berapa. Okay. Right. So, okay, kita tengok. Apa ni? W equal to mg. Lepas tu, make your G as your subject. W over m. Weight dia adalah 120 Newton. And then mass dia adalah 8. Berapa?
15 ms negative 2.
Berapa? 80?
15 ms negative 2.
15.
ms.
Tapi dia tanya dalam gravitational field strength kan? Kalau boleh, jawab dalam n kg negative 1.
Oh, okay.
Kalau kamu jawab 15 ms negative 2, saya terima sebab saya tahu dua-dua tu sama. Takut cikgu kamu terikat kaku dengan apa ni? Skema. Right. Is the planet bigger than the planet bigger than the earth? Give reason for your answer. Dia punya gravity 15 kan? Mestilah dia punya size kalau besar. Most probably the gravity is stronger. Okay? So we can assume yes, the planet, like we take for example the Jupiter. Jupiter is how many times bigger than the Earth, and it has the most powerful gravity. So yeah, when you have a more gravitational acceleration or gravity field strength, most probably your planet is bigger. Yes, because the gravitational field strength of the planet is greater than Earth's, which is 9.81 and kg negative 1.
Then sir.
Done. Okay, very good. Okay, now, finally, let us compare and contrast the mass and weight. Okay, mass. Simbol dia M, weight, simbol dia W. Okay, mass. The mass of an object is the amount of matter in an object, while the weight of an object is the force of gravity acting on the object. Changing of value. The mass of an object is fixed or constant everywhere, while the weight of an object varies or change with the magnitude of g of the location. Physical quantity dia, mass is a scalar quantity because it has magnitude, no direction. But for a weight is a vector quantity. Vector sebab weight selalu point towards downward, acting downward. Dia ada direction. Weight tak boleh pergi ke atas. Weight dalam apa-apa situation pun weight kena pointing downward. And type of quantity, a base quantity. Mass is one of the base quantity. Okay, base quantity. Can you list down other 4 base quantity? Or others 5? Yes.
Yes sir.
Other base quantity.
Derived quantity.
Base. Contoh.
Oh, mass.
Mass, selain mass. Length.
Length.
Lagi. Temperature. Electric current. Dan lagi satu. Lagi satu apa? Length, temperature, electric current. Electric current, temperature, length, mass. Apa lagi satu? Mass dah ada sini. Length, temperature, electric current. We use mole, right?
Oh.
Number of substance, kita guna mole. Okay. Ingat, ada lagi satu. Apa dia tu?
Luminous intensity.
Yang tu adakah dalam silibus kita? Ada?
Alasnya ada.
Ada? Luminous intensity adalah untuk A-level saya ada aja. For SPM saya rasa until number of substance of mole saja kot. Kita tengok chapter 1. Next week dah exam ni kena tahu basic unit there. No. One more. Ada luminous ada. Correct. Okay, length, mass, time. Yang penting tu, time. Time tadi missing. We got temperature, electric current, luminous intensity, ada, candela. And then amount of substances, we use mole. Right. Okay. Just to recap. Okay, we go to the next part. Type of quantity for the weight is actually a derived quantity. Okay. Right. SI unit bagi mass ialah kg. SI unit bagi weight adalah Newton. Kita bagi tahu jugalah kilogram. Lepas tu Newton.
Okay, done sir.
Okay. So can we discuss the momentum part? I end the recording here first. I'd start the new one for the momentum.
Okay, sir. But
Alright.
sir, I just saw the message for 7:30. My mom didn't tell me
Oh,
anything. But I
oh,
already done till question 10.
okay, but isn't it you have very long break?
Yes, but
Uh,
I just simpan ingat nak buat sebelum untuk revision.
okay, okay. Tak apa. Kita discuss yang lain dulu lah maksudnya.